In the previous video we loaded a network and showed you how to visualize and edit that, and looking at it using the tree view, the database graph view and the map. We also introduced you to the distribution analysis. In this video we're going to look at the distribution analysis in a little bit more detail and show you how you can synchronize that with the map, showing the properties on the map, and we will also show you how the distribution analysis is actually stored in the database. So there is the map we had before with the same network loaded as before. If we go to distribution analysis, choose the network, I'm going to choose the azimuth property I showed you before, because it's very easy to understand and you can see the clear pattern of peaks here around 0, 120 and 240 degrees. If you click on one of these, you'll see, as expected, all the antennas pointing to the bottom right are colored red. Those that are slightly deviating from that will be colored blue or green to these two sides. We can increase the adjacency slightly to see those that deviate even more. And of course pointing north or to the bottom left. Okay, azimuth is not the most exciting thing to look at. Something more useful for the 3G dataset we have here would be PN code. It's automatically divided them into chunks, ranges of about 10-11 codes in order to get a decent view here, but of course we know this is something we want to see as integers. So let's have a look. Alright, there are 2 on the map that I can see that are highlighted by that. Alright, finding objects with certain PN codes like this is somewhat useful. A perhaps more useful feature might be the star analysis up here, where you can select an individual sector and it will show you everything that has the same PN code. Okay, in a 3G network it's not that common to have the same PN code. There's one. Let's get out of the star analysis. Slows the map down slightly, and instead let's have a look at another property like antenna height. And with antenna height we might want to break it down into fewer steps, and that star analysis is remembering which one we selected, so it's showing us everything that has the same antenna height. Let's look at coloring the properties as well. Now we'll see that antenna that are very low are light in color, and those that are very high are dark in color, and you have a wide range of palettes to choose from for this as well. Let's switch this to logarithmic layouts as well so we see a better distribution. We can also see that most antennae are a similar height over here, and this is because this area of southern Sweden doesn't deviate that much in altitude. Well, something like a network analysis is quite interesting, but I think it's a lot more valuable to use these tools on drive data. So let's load some drive data. We have already imported previously into our database a large number of tems formatted drives. The loader we used for this was designed to filter on signals, so it's only looking at signals and it's pre-aggregated them to a certain resolution. So we have quite a bit of information, but it's not out of control. Here we just reorder this for the look. Now let's go back to that distribution analysis and analyze the drive instead. Because this drive loader was looking for signals, these are the options we see. So for example, dBm going from weak signals to strong signals. I've kept the logarithmic counts because if I didn't have that, you'd see quite an extreme peak over here. You might ask, why are there so many strong signals up here? That's actually because of this option, select max. This option is here because at each geographic location, you zoom in a little bit, you can see it. At each geographic location you get many signals. So these points really represent a physical location. I'll show you in the database view what that means. But at each point there are many signals. Which signal do we use to choose the color? Well, Max says take the strongest signal at that point and use that for the color. Let's say we use average instead. Suddenly we see the peak, especially if we go to logarithmic, is happening way down here in the non-logarithmic scale. So the average signal strength is not that strong. But there are still some with strong signals, not in this region. If I zoom out a little bit, now we can see some over there. Zoom in on that region. There we go. There's some areas where the signal is quite strong. In this range over here, -5 to -10. Now I mentioned how this relates to the database view. Let's have a look at the tree view of a drive. Here are many files, many more. We have over 200 files loaded. If I click on individual file, then you'll see in the map that file glowing. There it is. Obviously we can select several files and we'll see them glowing like that. As with the network, we can zoom in on a particular file by double-clicking on one of the measurement points, and it is centered over there on the map. There it is, the exact point that we selected. Click on that file and we'll get that entire piece of drive. So you can see there's one file to the left and one to the right. But what's really interesting down here is the database view, which has got a lot more complicated than before. Let's have a better look at that. What we see here is one of the measurement points, and of course there's the previous point and there is the next point, and there are all of these child nodes which are the actual signals measured at that point. If I click on one of these signals and go to the properties view, we can see that at that point we measured a certain channel code, and there is the signal strength and the milliwatt version of that. Whereas at the point itself we have the location primarily and when it was measured. So let's clean this up slightly so we can see better what's going on. These red relations, they are particularly interesting. Let's move them off to the side like that. What do we have here? Aggregate relations. We in fact have 1, 2, 3, 4 aggregate nodes. These are for the 4 particular statistics that were done involving these, or in particular this point. So these are in fact the bars in the histogram. If we look at the properties for one of them, we'll see it says that this is for a certain dB range, the min-max, a text name to display on the screen, what color to use, and the ID. So this is what is used both by the chart view and by the map view for deciding how to color things. The interesting thing here is you see that we have in the database both original loaded data as well as statistical results. As you perform analysis, more structure is added to the database. That is a very key feature of this application. It allows for considerable flexibility and power.